If you're using Kafka in .NET, you're probably writing hundreds of lines of code just to handle what happens when my consumer crashes, or how do I retry failed messages, or what happens when I'm consuming messages too fast. What if I told you there was a way to handle all of that in just 5 to 10 lines of code? That's exactly what we're going to talk about today with Akka.Streams.Kafka, the best Kafka client for .NET. Hello, my name is Aaron Standard. I'm one of the creators of the Akka.NET project, and Akka.Streams.Kafka is one of the most underrated parts of the entire Akka.NET ecosystem, and I'm glad to finally be able to do a video on it because we've made a ton of improvements to it this year. So let's go ahead and dive right in. So just to kind of set the table for you, Akka.Streams.Kafka is not an alternative to the Confluent library. Rather, it's a higher level abstraction that sits on top of it. Confluent.Kafka itself is actually just a wrapper around Kafka, which is a state machine that's responsible for dealing with basically satisfying the Kafka binary protocol under the covers. What Akka.Streams.Kafka allows us to do is basically kind of imagine our message processing from Kafka like a linear stream like this, where a message arrives, it enters the basically Akka stream processing, any error handling is subject to Akka.NET's supervision system, and then in the event that, let's say, the message gets handled as a result of, I don't know, maybe we go and save the content to a database or do some processing on it or whatever, we can go ahead and just automatically commit the offset and then rerun this process all over again. So it gives us a very linear, simple looking graph, and the actual syntax looks a lot like LINQ is what's going on here. If we compare that to trying to do this manually with a Confluent.Kafka raw consumer, we're going to have to write some of our own synchronization primitives, a lot of our own retry logic, and we're going to have to basically introduce our own method for basically dictating when an offset needs to be committed or not inside the system. By default, Akka.Streams.Kafka gives you a lot of options. You can go ahead and choose to automatically commit offsets as soon as you read the message from the stream. You can manually commit them later if you've done your processing. We give you a lot of flexibility and take care of the infrastructure concerns for you out of the box. We also do clever things like in the event of a partition rebalancing, we will automatically invalidate any in-flight messages that haven't yet been delivered to the stream so far. So that way you don't process any messages that are belonging to a partition that's since been revoked from you. So we're kind of trying to make Kafka feel like less of a distributed systems problem and more of a thing that just works. That's what we're trying to accomplish with our library. Now, one of the really big complaints about Confluent.Kafka is the lack of basically backpressure support. There's no IAsync enumerable or anything like that. Once you start polling for messages, you're expected to just do what you can to go ahead and process them. And that's a bit of a pain to manage. There's a number of open GitHub issues all complaining about this going back several years. And I kind of sympathize with the Confluent crew here. They're trying to build a really good first-party driver, and that's what they've done. And it's kind of up to you to manage application issues like backpressure. Well, this is where Akka.Streams.Kafka is very complementary to what the Confluent.Kafka driver does. What we do is that if Kafka is emitting events significantly faster than you can consume them. So imagine an Akka Streams graph that looks like this. We have Kafka, it's emitting events to the low-level Kafka consumer. That gets piped into our stream in Akka Streams. We emit this to your processing code. This is like your application or domain-specific code here. And one of the things you have to do as part of processing is maybe writing some output to a database entry somewhere. And let's say the database is the bottleneck inside your system. Well, if you've watched our video on the basics of Akka Streams, you'll kind of recognize this diagram structure, which is that the slowest consumer inside the system will basically dictate the rate at which events get emitted. This is in order to create backpressure load balancing inside the system. So if the database is going slow, this will send a signal to the processor saying, hey, you need to start sending me fewer messages until I catch up. This will then propagate that information to the stream. And finally, what the Akka.Streams.Kafka drivers will do is they will stop polling. They'll pause polling from the underlying Kafka driver until all of this demand has been cleared. And now we're ready to start processing new messages again, in which we'll start receiving them from the broker. And this doesn't cause any sort of continuity errors with your offsets or anything at all like that. All we're doing is the same sort of stuff you would need to do yourself with the low-level Confluent drivers. We're just managing it for you in a LINQ-like fashion that largely makes this type of problem invisible to you. Now, just to kind of sum up, I'm not going to go ahead and read this whole data table to you, But the bottom line of the pitch for using Akka.Streams.Kafka is a lot of these infrastructure and systems problems that would otherwise take a fair bit of code to write and manage yourself against the low-level Confluent driver is a total breeze with Akka.Streams.Kafka. And we're going to take a look at a sort of code sample that kind of compares these two in a minute, so you can kind of see for yourself what the difference is in terms of how much pain that Akka.Streams.Kafka can automate out of the picture for you using some of Akka.Streams and Akka.net's built-in primitives. All right, so we're going to dive into an open source code sample, and there's a link in the description to that. But the first thing I wanted to direct you to is the Akka.Streams.Kafka library itself. It's available as part of the Akka.net project. It's all licensed under Apache 2, so it's totally commercially friendly. We support this as part of Petabridge's Akka.net support plans if you're interested in purchasing one of those. But we routinely do work on this on our own. We just did a new release yesterday. So this library is pretty well maintained, and it's heavily used by a lot of our largest enterprise customers. So it's in pretty good standing. The application we're going to use today is our Akka.Streams.Kafka demos repository. So I'll include a link to this in the description. But basically it just has one application that's responsible for using Akka.Streams.Kafka to produce messages. And then we have two consumers. One is going to use the low-level Confluent driver. The other is going to use Akka.Streams. So we'll have a chance to kind of compare how those two work. And we're using, I think, the latest version of Kafka. We're using Docker Compose to go ahead and run it. And we're using the latest versions of .NET and Akka.net right now. So let's go ahead and actually open up the IDE and dive into the code. All right, so here we go. This is the Akka.Streams.Kafka demo solution. Now we have a few projects in here. The first one we'll take a look at is, this is our shared project, which has like a data generator and this little fake processor. Both applications are going to use this. We're going to produce some poison messages. So these are unprocessable messages, and they're going to go into a dead letter topic that we set up. And then we have some transient failure messages where we're going to have to retry those more than once just to kind of simulate some of the real world stuff you'll deal with in a really busy Kafka stream processing system. Then we have our data producer. This is using Akka.Streams.Kafka under the covers. Now, what we're doing here is we're using Akka hosting, which is basically our integration for working directly with the Microsoft.extensions ecosystem. So here I've got a host builder. This is just running as a console application. And all you have to do to get Akka up and running is call add Akka. And then I can actually delete this code down here. We don't need that. We're going to go ahead and call this line right here, add Hokon. This is going to bring in all of the defaults. Oops, didn't mean to do that. Go ahead and call, yep, there we go. That should work. We're going to go ahead and call this. This loads in all of the default Akka.Streams.Kafka settings. So if you want to do something like change the number of offsets that can be committed at any given time, this configuration file will kind of show you how to do that. We're probably going to introduce a C# configuration value for this pretty soon that leverages Akka hosting. So you'll just have a convenient one-liner right here you can call to kind of configure how all of your Akka streams are going to run inside the system. Now, if we scroll down a little bit further, this is mostly just boilerplate stuff. This is where things get interesting. This is part of the Akka.Streams.Kafka library. These are our producer settings. We're basically going to specify which servers are we connecting to and what serializers are we going to use. And I think we're just using the default UTF-8 serializers inside the Confluent.Kafka library. And then we generate some data. And if I scroll down here, what we're going to do is every 30 seconds or so, we're going to create a brand new Akka stream like this. So we're going to go ahead and create an IEnumerable of order events. We're going to turn each of those orders into a producer record, which basically includes the topic, and it's going to include the key for this particular order, for this object in here. So we're going to go ahead and inject both of those. And then we're going to basically pass in system.text.json and have it serialize that order. And we're going to call run with Kafka producer.plain_sync. We're then going to pass in a reference to our actor system right here. In fact, I don't even need this line if I don't want to keep that. And then this will return a task once that completes once all of these items have been saved to Kafka. So this is like a really simple producer. You could actually keep this Kafka producer alive, attached to something like a system.thread.channel if you wanted to. But in this case, we're just creating like little bursts of orders every 30 seconds. That way, the output we're going to see on screen is like not completely bonkers. That's the reason why we're doing that. Next, let's go ahead and take a look real quickly at the low-level Confluent.Kafka driver. All right, so this is just programmed directly against Confluent.Kafka. There's no Akka in here at all. So if we scroll down, the first thing you'll see here is that I have my consumer, this manual error handling consumer. So this is going to use none of the niceties that come with Akka.net. So no actors, no streams, no nothing, which means we are responsible for our own concurrent and async processing. So we're going to have a concurrent dictionary for keeping track of retry information for transient failures. We're going to have a concurrent queue for processing dead letters that need to be sent back to a dead letter topic in Kafka. We're also going to maintain a dictionary that has our pending offsets and a hash set that includes all of our assigned partitions. And then if we need to throttle processing in order to deal with like back pressure, we're going to use a semaphore for that. I've been doing concurrent and distributed programming in .NET for, I don't know, over 12 to 15 years now. This already looks like a lot of heavy duty stuff, but this is what the day in the life of a Kafka, like low-level driver programmer has to deal with, is this type of thing. So if we scroll down here, we're going to go ahead and create our consumer config. This is pretty similar to some of the things that we did with well, actually, we haven't seen our high-level Akka.Streams code yet, but this looks pretty similar. Both applications have auto-committing disabled. We're going to have to manually commit after we do processing. That's one of the things we want to kind of contrast here, is how easy that is to do in Akka.Streams.Kafka versus it kind of sucks if you're using the low-level driver. All right, so we go down here. We have our consumer builder. We're going to assign a partition handler. We're going to have a partitions revoked handler as well. And we're basically, when these events get invoked, we're going to go ahead and lock the assigned partitions. And then we're going to clear what was in there and repopulate them. I don't know if this code has any real handling for invalidating messages that are in flight. Probably not. But that's what we're going to try to do. If we get partitions revoked, we'll try to commit any pending offsets before revocation. That's standard practice. And then down here, we've got our partitions lost handler, which is another sort of standard thing. Then we're going to tell the consumer we want to subscribe to this topic. And we're going to start processing all of the different items that are coming in. All right. So until this cancellation token gets invoked, which Control-C will be what we have to do, we're going to try to consume as many events as we will receive by default every 100 milliseconds. And so if the consume result is null or if the partition is out of data, we'll go ahead and just loop over and start over again. Otherwise, we will go ahead and lock, check our assigned partitions. We're going to get to serialize each of these events and essentially attempt to process them. Let's see. Yeah, we'll go ahead and attempt to process them here. And then after all that processing is done, we will do a commit somewhere in here. Maybe the committing happens in here. Let's take a look. Commit offset safely. There we go. So we'll go ahead and try to commit the offset down here. This is a lot of complicated infrastructure code. This total file is about 400 lines. A lot of that is logging and a couple other things, but there's a fair amount of distributed systems programming type stuff you have to do working with the low-level driver. Now, if I go and run this sample, let me go ahead and run the data producer first. We'll get that up and running. You can see over here that my Kafka instance is up and running. Okay, we're going to go ahead and create a burst of 50 orders. That looks good. Let me go ahead and run my low-level Confluent driver as well. Let's see this thing go. So this is up and running. Let's process some orders. Let me shut the data producer down for just a second. All right, there we go. All right, cool. So that thing should completely shut down in a second. There we go. So if we take a look through here, you can see it is processing, so it is working. It's logging some transient failures that are in here. Yeah, basically we're kind of simulating some service outages. We're just trying to kind of illustrate what a real application might have to deal with. You see some of that in here. If I look around, yeah, here we go. Poison message detected. That's going to go into our dead letter queue. That's going to get moved into there. And this application works, but it's just a lot of code to go ahead and write and maintain it. So let me go and shut that one down. Let's compare this to the more high-level Akka.Streams implementation. So here, again, we're kind of doing what we did with the producer application. We call add Akka. This gives us our actor system that we need. We go and we start the host. And then down here, I am going to grab a reference to our actor system. And we scroll a little further. We're going to create our consumer settings. And this is more or less doing the exact same thing that the consumer builder did inside the low-level Confluent calls. But we're going to do a couple other things too. We're going to create some committer settings. We're going to space on the Akka.Streams graph our source that's going to read from Kafka and our committer are going to be in two separate stages. And in between those two is going to be our actual work and our dead letter queue system as well. And we're going to create a separate producer for managing the dead letter queue system. So this is going to write back to Kafka under a different topic for any message we encounter that's unprocessable. So then down here, this is not quite 5 or 10 lines because we have a lot of realistic looking error handling is what I've added here. We're also manually committing and we're doing a lot of logging. So we've kind of fleshed this out a bit more than what, let's say, a minimal Kafka, the Akka.Streams.Kafka sample would look like, but that's okay. It's still going to be radically simpler than what we were trying to do with the Confluent.Kafka before. So we're going to create down here a committable source. This means that this is going to read from Kafka and produce messages that can be committed later. And then we're going to pass in our set of topics that we're subscribing to here. We can subscribe to one or more topics anytime we want. And then we have the first one of our real base Akka.Stream stages, select async. We have a degree of parallelism. This means we can process up to 10 messages concurrently. Now, one thing that's interesting about select async, this method will only emit events in the order in which they were originally invoked. So if I process the very first offset that came from Kafka, but I also decide to process 9 others in parallel, I cannot emit any other offset until the very first one completes down here. So this basically preserves order, even though it allows parallelism. So that's kind of an important facet of how the stream stage works. If you need to go ahead and commit offsets in order, which you do, this will give you the ability to do that in parallel while still conserving that order. That does come at the cost of a little bit of throughput, but it's still way faster than what you were doing with the low-level Confluent program. So it kind of works out either way. This is where we actually do our processing right here. And if the processing was successful, we go ahead and return this tuple. If we get a poison message exception, we will go ahead and log that, and we'll pass along a tuple as well. And if we get a processing exception, here's what's interesting. We can go ahead and throw an exception here, and Akka.NET supervision system down here will go ahead and restart the Akka.Streams source, and we will resume processing from the top again. Now, if you are worried about, let's say, multiple messages getting reprocessed more than once, the fix for that is just to drop the degree of parallelism down to 1. Now you won't have that problem. Or possibly, you might want to not throw an exception. You might just want to go ahead and return an error, or maybe do a retry directly inside the method right here. Those are both ways of avoiding that particular problem. But we did want to show how easy it is to say, hey, you can just reboot your entire Kafka consumer and all the processing downstream anytime you want by using the supervision directive here. That's pretty nice and convenient. Now, the next stage we're going to look at is another select async. This is our dead letter queue system. We're going to take a look at the tuple that came in, and if the tuple is not a failed order, then we're just going to go ahead and return the offset. We're not going to bother running any of this code. If we make it down here, it means that this message failed processing in some significant way. Usually it means that we got a poison message exception. Well, if that's the case, we're going to go ahead and turn this into a new producer record, and it's going to go into the dead letter topic. That way someone can pick it up and analyze it down the road, and maybe a human operator will need to manually do an entry or something in order to fix that. So that's what we're doing down here. And we're still able to go ahead and use that plain sync we created earlier to go ahead and write this single message out to it. Well, that's pretty convenient. Otherwise, down at the very end of the graph, we pass in our committer.sync. This is going to commit offsets in batches to Kafka behind the scenes as we're processing. And this will essentially ensure that by the time an offset gets committed, it's already fully processed. So we don't have that problem if we're using, let's say, auto-committing, where you can auto-commit an offset and then the processing fails, and now it's up to you to go ahead and manually reprocess it. Akka.Streams takes care of all that for you. And even better, if we scroll down here a little bit further, two of the return values that we returned when we originally created our stream is we have here this I control. This is what's called a draining control in Akka.Streams.Kafka. This helps us ensure that if we shut down our application, that all of the messages that are in flight get fully processed before we terminate. That way we can go ahead and make sure no one missed anything. And this task right here just kind of signals when the stream is no longer emitting new events. So it means we've stopped reading from Kafka when this returns true. So what I'm doing down here is I'm going to hook into Microsoft.extensions.hosting's application lifecycle methods and register this little hook right here where I'm going to say, I want to call drain and shut down and pass in this completion task from the stream. And this will go ahead and cause us to completely drain any messages that are in flight, stop emitting new ones, and once everything is fully processed, this task will complete, at which point we can go ahead and safely shut down the application. So let's see how well this works in practice. I've got two little windows here. Let me go ahead and run my data producer again. And let me go ahead and run my high-level Akka.Streams example. All right, we're going to start one of these. And this thing ripped on through all of its orders. We see down here that we restarted our stream processing for a couple of failed transient orders. Now again, I could go ahead and amend that so we handle the retries natively in here rather than using supervision. But we're just trying to show you what's available as far as options go. All right, now one thing I kind of goofed on, I had to make some code changes at the demo, is I forgot to add multiple partitions to our topic that we're publishing. So I can go ahead and show how we can distribute this work out across multiple clients. So if I scroll down here, here we go. Yeah, we're using the Kafka admin client to go ahead and basically specify that this topic has 3 partitions. So we should be able to demonstrate how rebalancing can work across multiple consumers using Akka.Streams.Kafka. The Akka.Streams.Kafka code is totally unchanged. This was just a configuration issue we needed to solve on the producer. So let me go down here. We'll go ahead and start the producer back up. And that should go ahead and confirm that we have, let's see, there we go, topic created with 3 partitions, great. Let me go over here to our high-level client, and I'll call, scroll down real quick, .NET run, C release. We'll go ahead and create client 1, and this should go ahead and process a burst of messages there. There we go. The same sort of processing output that we saw from earlier. Now let's go ahead and start a second client, .NET run, we'll call it 2. So this is instance 1. This is instance 2. We're going to wait for actually I'll just go ahead and force the data producer to restart. That way we don't have to wait 30 seconds. All right, let's go ahead and run that. And you can see down here, both of these are active. So they're both getting additional messages from Kafka. And if I go and shut one of these back down again, that stream completed gracefully because basically we had fully processed everything in our partition. All the partitions will now be handled again by this process here. Now I could add some logging that can go ahead and illustrate that, but generally we try to abstract that away so that's not something you have to worry about. Akka.Streams.Kafka is very easy to get started with, and the last thing we're going to cut to is talk through all the different ways you can actually go and work with it. So let's go ahead and take a look at that. All right, so we're back to the Akka.Streams.Kafka GitHub repo. Now, there's a lot of different ways you can actually work with it. For starters, we've just taken a look, I think, at the committable source. The plain sync is what we used for writing, and then we use the committer sync as well. Well, you can also do things like have a Kafka producer sitting in the middle of a stream if you want to, which is essentially what we were doing with our dead letter queue. We support the ability to go ahead and, let's see if I scroll down here. As far as some of our consumer settings go, let's see, we've got our plain source, which basically just auto commits and reads directly from Kafka. This is like our simplest possible sort of consumer here. The committable source, which is my preferred go-to that I like to use when I'm working with Kafka. We also have a partition source that allows you to take multiple partitions and run each partition as its own substream in parallel. That can be really useful, particularly if you're subscribed to a large number of partitions. And then basically we have a whole menu of different sources down here. You can take a look through all of it. We have something like, I think, 1 or 2 dozen different available Akka stream stages, a combination of committers, sources, and syncs. So please go ahead and give it a try. Don't forget to check out our Akka.Streams basic video and join the Akka.net Discord if you have any questions about working with Akka.Streams.Kafka. It's really easy to get started with. It's Apache 2.0, and it'll simplify a lot of the infrastructure problems you've inevitably had to deal with working with Kafka directly using the Confluent drivers. Thank you. Well, that'll do it for this video. If you found this video useful, please don't forget to check the description to find links to other resources we may have included, so blog posts, GitHub code samples, other videos, so on. And as always, don't forget to like and subscribe and ring the bell for notifications. We'll catch you next time. Thank you very much.